Okay, so the idea now is to talk about the correlation coefficient formula, which evaluate how much there is correlation, linear correlation between the two variables x and y. So this is the correlation coefficient of x and y. It is calculated by calculating the covariance between x and y and dividing by the standard deviation of x multiplied by standard deviation of y. Now, let's open the formula. So the formula for the covariance of x and y is, as you can see here, this is the covariance of x and y. And those are the standard deviations that are calculated. I calculated one time for x and one time for y. Those are the standard deviations. Therefore, we get this formula, and when the correlation is 1, it indicates perfect positive linear relationship, and when it is -1, the range is between 1 and -1, it indicates perfect negative linear relationship. Namely, when it's 1, when one variable gets higher, the other one also gets higher, and like this. And when it's -1, it's exactly the opposite. When one of the variables gets bigger, the other one gets smaller. So it's like this one, the correlation. Okay, so for example, for calculating the correlation coefficient for an example, you can see here x has this instance and y this, and we are asking what is the correlation, the linear correlation between the two. So we will calculate the formula. We are starting with calculating the means, and then we can get the covariance like this one. We need the means for this here, and we can calculate the covariance and divided by n minus 1 because we are taking it for a sample and not from the population. The mean, we calculated the mean from the sample, and after this we will calculate the standard deviation like this one and not this one. This is from the population, this is from the sample. Look that this one is n minus 1 and here it's n, and this is the sample mean and this is the population mean. The same goes for the covariance. This is n minus 1 and this is n for making it unbiased, and this is the sample mean and sample mean, population mean and population mean. So this is the difference. We are using the sample mean, so we will use the formula with n minus 1 here. This is the covariance, and we calculate this and get the result. And this is the standard deviation. We calculate this as well and get the result for the standard deviation for x, standard deviation for y, and then we can compute the correlation coefficient, which is the covariance between x and y divided by the standard deviation of x multiply standard deviation of y, and we get the coefficient, which is positive, almost 1. Therefore, we conclude that there is a positive correlation that suggests a strong positive linear relationship between x and y because it's positive number and it's close to 1. So it's strong positive linear relation between the two variables between x and y. So this was a very simple example and explanation about the correlation coefficient between two variables between x and y, as you can see here. This is for linear relationship evaluation between variables. Thank you very much. If there are any correction or mistakes, please correct me, and that's it. Thanks for ChatGPT for creating this doc for me.